correct, my fellow geothermal students. Now we're going to take a look at this as the instructor copy, so pay no attention to these grayed out areas. Hopefully you've got a chance to look at this Geothermal Today DOE article and unlimited attempts at that quiz, week 9 enhanced geothermal energy system quiz, geothermal systems quiz. And then we got started on our lectures last week in topic 10 and got down into started to get a feel for the geothermal generated geomagnetics. Let's take a look at some of the results of this. Here we go. Results of the solar flares on geomagnetics, geothermal energy.
Good morning, folks. Here are the photos from Hawaii thus far. The lava is really creeping in there. Can't help but feel like this guy's way too close. Anywho, the town is about one surge or wrong turn away from an evacuation. It's pretty much a slow-moving nightmare. Okay, let's get to it. The biggest sunspot of not just this solar cycle, but the biggest in nearly 25 years, kept firing away in the last 24 hours and continues into the morning. We've had 3 M flares and an X-class blast from the region, but still no ejecta, no CME, and no real danger. The plasma movement within the group and the surrounding regions was in last night's evening news. Try to note the direct currents of ionized iron within the umbral magnetic fields.
So when you start to look at the actual pattern here, the magnetic flux lines that we see on Earth in the northern lights, hey, see any correlation between what you see on the sun?
Their movement illuminates where this flare energy comes from. Highly complex even still. At this time we are just about ready to say goodbye to the region. We'll maybe get some parting shots before he goes. Other top solar news includes above average solar wind speed and some magnetic perturbations that have Earth's magnetosphere in a bit of instability at the moment. On the filament locator at ISWA, we note the many small ropes down south and the big one up north. The big one is easiest to see when viewing the entire Earth-facing disk, a significant solar figure, but one that has held tight thus far. Smaller ones down below are visible as well. The ones incoming at the eastern limb appear to be comprised of 3 or 4 solar tornadoes reaching up from the surface and connecting in the corona just above the interface region. In terms of coronal holes, the one down south is easily visible, but you can also see one up north coming in simultaneously. The umbral and coronal fields reveal an unimpeded southern opening, but some blockage of the northern positive hole. This is why ISWA shows the southern opening to be tremendously powerful, but the northern opening not so much. It's hampered by the coronal magnetic fields. With 2 coronal holes on the Earth-facing fourth of the star, we got a slight seismic uptick. Top rumble being in the western Pacific. They've settled on Tonga as the epicenter in just over 6 magnitude range. Top link for today is from Chandra. The X-ray experts have compared Virgo to Perseus in pretty good detail, especially in terms of star formation. EU proponents grit your teeth to get through their choices in diction. So here's our Indian Ocean cyclone. Precipitable water overlay reveals the flood risk for when it will swing west and make landfall. Won't be for a few days yet. We've got 2 notes at Central America, 2 lows. One made landfall and is considered storm remnants but still a flood advisory, and we wait for model confirmation about where the new storm is heading. Just to the north, we see a low in south central Canada.
So notice this is October 28th, 2014. So, and what we're looking for here is not current information, although relatively current, but we are just exiting another solar event currently, and it's related to the earthquakes that we lectured on last week and some of the seismographic readings that we got out of Yellowstone. And What we want to look for here are the patterns, the cyclonic patterns, or the tornadic, what do you call it, solar tornado. Actually, vorticular energy vortex. It has a, you can see it out here. We've got El Nino this year.
Of bringing hot, wet air up the eastern side of the convergence and cooler air around the western side, collision in the middle. We've also got the moisture flow off the Pacific low remaining. The convergence will produce severe weather this evening. Please check your local forecasts here, and the western rains will continue with some snow in the mix as well, where the cooler air catches that flow in and around the Rockies. Europe, major convergence to be seen there, pretty solid off the northern low.
So here you see where the El Nino effect, you can see it right in here, it was on the other side of the world last year about this time, and it's worked its way around, and you start to see that not as many vortexes, or not as much rotation, more linear waveforms here.
Also, the temperature suggests some energy in the Mediterranean due south of that as well. Floods and high wind watch at the convergence, lightning alerts to the south. You've got that same moisture flow as yesterday here, accompanied by two well-seen convergences, one there and another forming over New Zealand. It will rain over wide portions of those areas, but the storms will stick to the convergences. Got some shots of our star to close at 6:05 a.m. Eastern Time, 5:05 a.m. Central. That's the news. Eyes open. No fear. Be safe, everyone.
Coronal mass ejection is pretty heavy duty stuff, and then when it's pointed straight at the Earth, that's when we get the full brunt of the solar wind and get the greatest potential for northern lights. Notice the Earth scale over here to the right hand side. See my little pointer over here on the right hand side of your screen. Either scale of the Earth in relation to the Sun. Yeah. Sweet, huh? Okay, I want you to look and see now if you see any correlation between the waveforms here. Stuff we just saw in the sun. So when you start to see the red, the coloration red, this is real common. The green and white, but the red is more intense, and then you even get purple and blue. You can see the relation to the CME, the coronal mass ejection, the waveforms. See the red at the lower frequencies, higher frequencies here, as the ions are activated as they travel in on the magnetosphere. Solar wind comes in and the particles are ionized. Baja, Cabo San Lucas, Gulf of California. Yeah. I don't know about you guys. I want to go up there.